All right, so today we're going to talk about linear inequalities. And a linear inequality is an inequality in two variables, typically x and y. And the reason why they're linear inequalities is because when you have two variables, we'd end up graphing these inequalities on the coordinate plane. And we end up getting a boundary line, just like when we graph equations, we get a line. When we graph inequalities, we get a boundary line that kind of splits the graph into two sides, two halves. One side that contains all of the solutions, that's the shaded half plane, and then one side that contains ordered pairs that are not solutions to the inequality, and that's not going to be shaded on that side. So for every inequality that we take a look at today and eventually graph, we are drawing a boundary line, and then we are also shading the half plane, the half side of the graph that contains all of the solutions. All right, so what is a solution? So when we're working with inequalities, and that's like, it's like you might want to call it an equation, but it's not because it doesn't have an equal sign. But if we had something like this, 3x plus 2y is less than or equal to 7. That's an inequality. A solution to that inequality is any ordered pair that makes it true. In other words, it would make the left-hand side less than or equal to 7. And there's a lot of different x and y pairs that would make that true. Let's look at an example. So here we're going to determine if these 2 points, A and B, are solutions to this inequality. X plus 2y is greater than 3. So all we have to do for this is substitute the values of x and y from our ordered pair into the inequality and check to see if it makes the inequality true. If it makes it true, the ordered pair is a solution. If it makes it false, the ordered pair is not a solution. So we're working with x plus 2y is greater than 3. When we substitute, the value of x is 2 for my ordered pair, because remember x is always the first coordinate, y is the second coordinate. So y is 3. And we just need to do a little calculations here. We multiply first, so 2 times 3 is 6. And then 2 plus 6 is 8. So we get this statement that 8 is greater than 3, which is true. Now remember, it doesn't mean that they have to be equal. It actually means the left side has to be bigger than the right-hand side. Now, because this is true, true isn't the answer, by the way. So I'm going to put that in parentheses. But because that's true, point A is a solution. It would be on the shaded side if we were to graph this inequality, or possibly on the boundary line. But because we ended up getting two numbers that were different in our inequality down below, it's going to be on one side of the boundary line, the shaded side. For example, B, let's do the same thing. Start with our inequality, x plus 2y is greater than 3. We're going to use substitution to substitute our values of the variables. X is negative 1, y is 2. So we get negative 1 plus 2 times 2 is greater than 3. I make sure to follow PEMDAS and multiply first. 2 times 2 is 4. And when I add those together, negative 1 plus 4 is 3. So I get 3 is greater than 3. Now you might be tempted to think, oh yeah, that's true because I get the same number on both sides. Well, that's how it worked with equations. But with inequalities, remember, it's unequal, inequal, however you want to say it, they're not equal. So is 3 greater than 3? No, it's not. This would be a false statement. Now, because it's false, we can say that negative 1 comma 2 is not a solution. If we were looking at the graph of this inequality, that means that that ordered pair, point B, would be on the side of the boundary line that's not shaded, because that's where all of the other non-solutions are. Let's take a look at how we would tell by looking at a graph what the solutions look like. So on a graph, a solution is an ordered pair or a point on the graph that is either in the shaded area or on a solid line. If the ordered pair, the point, is on a dashed line, then it's not a solution. Okay? So it's a solution if it's in the shaded area or on a solid line. But if it's on a dashed boundary line, then it's not a solution. Let's look at an example. So here we have three more ordered pairs, point A, B, and C, and a graph of the inequality. And we don't know what the actual inequality looked like, but what we do know is on the graph, we have a dashed boundary line, and everything is shaded above the line, or kind of the upper right-hand side of that line. So what we want to do is plot each point, A, B, and C, and determine if that point represents the solution based on what we see. So let's start by plotting points. Remember, it's always x comma y. So for point A, I'm going to go 2 in the x direction and 3 in the y direction. So there is point A. Because point A is clearly in the shaded area, it is a solution. Any ordered pairs in the shaded area represent solutions. Point B is at -1, comma 2. So -1 in the x direction, 2 in the y direction. And I notice point B is right on the boundary line. It's a dashed boundary line. Let's go back to our notes. We said if the ordered pair lies on a dashed line, it is not a solution. So point B is not a solution. And that's because it was on a dashed boundary line. Had that been a solid boundary line, then it is a solution. So we got to be careful about ordered pairs or points that are right on the boundary line. It's only going to be a solution if it's a solid boundary line. It's not a solution if it's on a dashed boundary line. And we'll talk about how to tell the difference between solid and dashed lines with the inequalities in our next video. All right, point C, last one. We have -4, -2. So I want to go -4 in the x direction and -2 in the y direction. I'll label that point C, which we can see is clearly on the side that is not shaded. So point C is not a solution. So when you're looking at a graph of an inequality, solutions are in the shaded area of the graph, or they could be on a solid boundary line only, not a dashed boundary line. So on a solid line or in the shaded area for the solutions.